Okay, probability and odds. This is just kind of a basic. Everyone put your iPads away now.
If you heard this, you'd be so sad.
Okay, probability of an event. I think everyone knows what that is, what it stands for. Probability is just the percentage that something may happen, right? You guys know that? Or the fraction that it may happen. The outcomes is how many things that can happen. For example, if you roll a dice, how many outcomes are there? Six. You can get a 1, a 2, a 3, a 4, a 5, or a 6. Favorable outcomes is what you want to happen. So, if you roll a dice and you want to get a 2, 2 is the favorable outcome. So, theoretical probability and experimental probability are done the same way, they just relate to a different problem. To find both of these, what you do on a probability is you take what you want. So like if you're rolling a 2, how many 2s are there? 1. Divided by the total outcomes. So to roll a 2, there's 1 2 on a dice, there's 6 things that can happen. So the theoretical probability is 1 out of 6. You can leave it as a fraction, you can write it as a decimal, you can write it as a percent. Any way is fine, however you write a probability. The theoretical probability of flipping a heads is 1 out of 2, 50, yep, 50%. 1/2 or 0.5 or 50%. Experimental probability, it's done the same way. The only difference is it's an experiment. You use the actual numbers. So what happens is someone did an experiment and then they use those numbers. For example, if you flip a coin 100 times, is it going to be 50 heads, 50 tails? No. So say they did an experiment and they got 47 heads and 53 tails. And they asked you, what's the experimental probability? You look at the numbers they got. It was 47 out of 100. Okay? What you want over the total. Odds. Odds and probability are very similar. To figure out odds, you take what you want, which means the top number is going to be the same as the probability, but you obviously can't put it over the total because then it'd be the same as a probability. So for example, what's the theoretical probability of they would write it like this, roll a 2. A P in with parentheses, this just means the probability of rolling a 2 is 1 out of 6. The odds of rolling a 2, the top number is going to be 1 because that's how many things that can happen that you want. Any guess what the bottom number would be?
1.
Nope. It can't be 6. It can't be the total because then it'd be exactly the same as probability. Someone's got to be able to guess it. 1 over what? Take it right. Nope, not 1 over 2. 4's not right. 3's not right.
100.
Nope.
50.
No.
12.
200.
No.
400.
0.
It is an odd number.
3.
Nope.
6.
Someone said it. 5. It's 1 to 5 to the odds of rolling a 2. Now, any guess what that means that goes on the bottom? It's what you want over
Total, like
The rest.
all.
what's left. What you don't want. So, these two numbers are always going to add up to the total amount. So the odds of flipping a heads, how many heads can you get when you flip a coin? It's 1 out of 1. How many won't be heads? Tails. So the odds of flipping a heads is 1 to 1. Okay? So finding a probability, these are the simple ones. They randomly select an animal. There's 12, 10, 5, 21, 4, and 5. What's the probability P that you get an elephant?
You add those up.
So 10, there's 10 elephants. And then you gotta find the total outcome, so you gotta add all these up. They add up to 60. So, there's nothing wrong, unless they tell you to simplify it, to leave it improper like that. 10 out of 60 is correct, because that's a probability. You can simplify it if you want. The zeros would just cancel. You could write it as 1/6. Usually fraction's a lot easier to do, because you don't need to get a calculator. But if you did write a decimal, 1 divided by 6 is 0.16 repeating, which, if you move it 2 spots, you'd get 16.6 repeating percent. Now, if they asked for the odds of an elephant, what would the odds of you getting an elephant out of that baby? 10 out of 50, right. Because it's what you want over what you don't want. We have some problems today where they give you the probability and they ask you to change it to odds. So just remember the top number stays the same. To figure out the bottom number, it's basically you just subtract those two. If there's 60 things and there's 10 of them you want, that means there's 50 that you don't want. So here's another probability. It's an experimental probability. You do it the same way, you just use the numbers that they found. This has a primary source of research for a school paper or project. They want the probability that a randomly chose internet user, blah, 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 uses the internet and library equally. So the probability of that would be, what's the top number? 30 over the total, which you'd have to add all these up. $754. So the probability is 30 out of 754. You could reduce it, you could make it a decimal. It's going to be a long decimal, so you're better off just leaving it as a fraction. Now, if they ask for the odds, the odds would be the top number's the same. It's still what you want over what you don't want.
724.
So you subtract these two. 724. Remember in the odds, these two will always add up to the total amount. So you randomly choose an integer from 0 to 9. What are the odds the integer is even? So there's 1, 2, 3, 4, 5 evens. And then what would the bottom number be for odds? 5. Because there's 5 that are not even. 5 to 5, or you could write it as 1 to 1. Finding the odds from a probability. They tell us the probability of using a personal use vehicle is 77/100. Find those odds. 77 over
33.
close. 23. The top numbers stay the same. 77 you want, 23 you don't want, and the way you figure that out is you just subtract these two. There's 77 you wanted, there's 100 total, so you subtract them. Now sometimes they try and trick you a little bit. Make sure you're reading. It'd be the same type of problem. They'd say find the odds in favor of not using a personal use. So this is the probability of using. So what would the odds of not using one be then? There's 23 that you would want to happen, since there's 77 of the personal use, there's 23 of the others. And then 77 is the rest of them. Okay, we already did that one, so. All right.